Google Cloud runs on Google's own global network. It's the largest network of its kind, and Google has invested billions of dollars over many years to build it. This network is designed to give customers the highest possible throughput and lowest possible latencies for their applications by leveraging more than 100 content caching nodes worldwide. These are locations where high-demand content is cached for quicker access, allowing applications to respond to user requests from the location that will provide the quickest response time. Google Cloud's locations underpin all of the important work we do for our customers. From redundant cloud regions to high-bandwidth connectivity via subsea cables, every aspect of our infrastructure is designed to deliver your services to your users no matter where they are around the world. Google Cloud's infrastructure is based in 5 major geographic locations: North America, South America, Europe, Asia, and Australia. Having multiple locations is important because choosing where to locate applications affects qualities like availability, durability, and latency, the latter of which measures the time a packet of information takes to travel from its source to its destination. Each of these locations is divided into several different regions and zones. Regions represent independent geographic areas and are composed of zones. For example, London, or Europe West 2, is a region that currently comprises 3 different zones. A zone is an area where Google Cloud resources are deployed. For example, if you launch a virtual machine using Compute Engine, it will run in the zone that you specify to ensure resource redundancy. You can also run resources in different regions. This is useful for bringing applications closer to users around the world and also for protection in case there are issues with an entire region, such as a natural disaster. Some of Google Cloud services support placing resources in what we call a multi-region. For example, spanner multi-region configurations allow you to replicate the database's data not just in multiple zones, but in multiple zones across multiple regions as defined by the instance configuration. These additional replicas enable you to read data with low latency from multiple locations close to or within the regions in the configuration, like the Netherlands and Belgium. Google Cloud currently supports 121 zones in 40 regions, although this number is increasing all the time. You can find the most up-to-date numbers at cloud.google.com/about/locations. The virtual world, which includes Google Cloud's network, is built on physical infrastructure, and all those racks of humming servers use huge amounts of energy. Altogether, existing data centers use roughly 2% of the world's electricity. With this in mind, Google works to make their data centers run as efficiently as possible. Just like our customers, Google is trying to do the right things for the planet. We understand that Google Cloud customers have environmental goals of their own, and running their workloads on Google Cloud can be a part of meeting those goals. Therefore, it's useful to note that Google's data centers were the first to achieve ISO 14001 certification, which is a standard that maps out a framework for an organization to enhance its environmental performance through improving resource efficiency and reducing waste. As an example of how this is being done, here's Google's data center in Hamina, Finland. This facility is one of the most advanced and efficient data centers in the Google fleet. Its cooling system, which uses seawater from the Bay of Finland, reduces energy use and is the first of its kind anywhere in the world. In our founding decade, Google became the first major company to be carbon neutral. In our second decade, we were the first company to achieve 100% renewable energy. By 2030, we aim to be the first major company to operate completely carbon-free.